can neither be created nor destroyed. If mass can neither be created nor destroyed, therefore the total mass on the reactant side should be equal to the total mass that we get from the products, right? And for that, what do we need to do? We need to balance the number of atoms participating in the reactant side, and then we get on the product side, right? The combination might change. But the number of atoms will still be the same, right?
Yeah.
Fine. So now, how do we balance the chemical equation? This you are going to learn, okay? How are we going to balance the chemical equation? So first of all, any chemical equation will have the reactants. Yes, whatever number of reactants could be there, we'll just add a plus sign and we'll keep on writing them all the reactants. Yes, and on the right hand side, we get the product, right?
Yeah.
Something like this, and we will denote. We will have this arrow here in between that will tell you the direction in which the reaction is proceeding, right?
Yeah.
Yep. And what was the other important thing? That we need to denote the physical state of the reactants and the product.
Yeah.
Okay. Yes. Sorry for the disturbance. So physical state of reactants and products has to be written. If it is solid, we'll write S, right? If it is liquid, we'll write L. If it is gaseous, we'll write G. And if the substance has been mixed with water, that means aqueous form, okay? We'll write it using AQ,
Yeah.
right? That has been discussed, fine. Now, see, how do we balance the equation? So there are 4 steps, Abdul. If you follow that, the balancing of chemical equations becomes very easy, okay? The first step is,
Yeah.
bache, balance the metal, balance any metal present on both reactants and product side, okay?
Yeah. 1 second, I'll write.
Yes. And what are the examples of metals? I'll write it here. See, sodium is a metal, potassium is a metal, and see, we are always using the symbols in the chemical equation. Yes. So therefore, be careful with the symbols, okay? Please know that what symbol is used for what element, okay?
Yeah.
So you're writing this? Just give me a second.
Yes. Yes.
Just a second, bacha.
Okay. Okay.
We discussed the skeletal chemical equation, right?
Yeah.
Yeah, fine. So basically, the equation which is not balanced but is representing the reaction is called as skeletal equation, right? Skeletal chemical equation. If you balance that equation, that is called as balanced chemical equation, okay?
Yeah.
So metals are sodium, potassium, calcium, magnesium, okay? Zinc, iron, aluminium, silver, gold, copper, okay?
Yeah.
Lead. All of these are examples of metals, okay? Mercury.
Yeah.
Should I move on to the next point?
Yeah.
Second point is after the metals have been balanced. Let's say we had 2 metals in the equation, okay? So you can balance any of them first, and then after that you balance the second metal. That's it. Then move on to the next step, okay? The next step is balance any non-metal, okay? Balance any non-metal present in the equation.
Yeah.
Clear? Now what are the non-metals? Nitrogen is a non-metal. Carbon is a non-metal. Okay. Sulfur is a non-metal. Phosphorus is a non-metal. Chlorine is a non-metal. Iodine is a non-metal. Bromide is a non-metal. Fluoride is a non-metal. Okay. So all of these are
Yeah.
non-metals. Oxygen is also a non-metal. Oxygen is also a non-metal, but since it is so very prevalent in the chemical reactions, we use a third step just to balance the oxygen. Okay. So in the second step, do not focus on oxygen. Focus on all other non-metals. Clear? Now the third
Yeah.
step is balance oxygen.
Yeah.
Clear? Fourth is last step, that is balance hydrogen. Balance hydrogen. Clear? Write it quickly and then we'll discuss the examples here. Just a second.
Yeah.
Hmm.
Balance any
Should I give
non-metal.
you the example? Have you written this down?
Wait. Non-metal
Okay.
present in the
Equation.
equation.
This is
In
a
the
symbol for equation. Okay. EQ ratio to the power n.
equation. CSPCl. What is I?
Iodine.
Oh, balance oxygen. You're done.
Done. Write the third and the fourth step. Bacha.
Balance hydrogen.
Right? Fine. So let's quickly see the example here. Okay. Then
Yeah.
first learn bacha how to approach the questions. Okay. I'll discuss this example with you. Then next you will see. Okay. So this is the equation. Now first see, this is the chemical equation which is representing the reaction taking place using the symbols. Okay. First point. Therefore, it is a
Yeah.
skeletal chemical equation. Okay. Second point, first see is the chemical equation not balanced? First check that. Okay, is the chemical equation not balanced? Check it.
Yeah.
How do we check it? We'll check the number of atoms. Okay, see, we have how
Yeah.
many atoms here of iron? One. Yes.
One.
How many atoms do we have here?
Three.
Three. So clearly it's not balanced, right? So therefore we need
Yeah.
to balance the equation. Yeah.
Yeah.
Now, in this chemical equation, bache, how many elements are present? First see that and tell me how many elements are present.
Hydrogen is two. And
Iron
so
is
we got
present, right?
Fe3. Yeah. Three Fe.
No, no, just tell me the element's name. Okay, iron is present, hydrogen is
Hydrogen.
present, and oxygen is
Oxygen.
present, right?
Yeah. Yeah.
Right. Now see, what is the metal from this? What is the metal from this?
Fe.
Fe. Good. First, we will balance the iron. Okay. So see, on the reactant side, bache, how many iron atoms are there?
Left side or right side?
This side, reactant side, left side.
One.
One, right? It is one atom. How many are there on the product side?
Three.
Three. So I will have to balance it. So what I'll do is that I'll add a three before iron on the reactant side. So now my equation, my concerned equation is this. Yes.
Yeah.
So now see, is iron balanced now?
Yeah.
It is balanced. Now we'll move on to any non-metal. See, there is no non-metal here, right? We saw the
Yeah.
element, no non-metal. So should we move on to the third step, Acha? That is oxygen.
Yeah.
So this is my equation now. I'll be balancing the equation using this equation now. Fine. How many
Yeah.
oxygen atoms on the reactant side?
Um. One.
One. How many on the product side?
Four.
Four. What do I do? Should I add a four before H2O, right? Now I
Yeah.
get this equation, right? Now see, is oxygen balanced?
Yeah.
Now check whatever last step we did. Whenever you do the next step, check for the last step. See, is iron is still balanced because of the balancing of oxygen?
Yes.
It is balanced. Now should we move on to the last step, Achi? That is hydrogen.
Yes.
Now which equation should I consider as my standard? Should I take this one, right? My concerned equation.
Yeah.
How many iron or how many hydrogen atoms here?
Two.
Mm-hmm.
Four.
Four. How many here?
One. No, no, two, two.
2. What do I do? If I have to make it 4, can I add like this?
Yes.
Mhm. So now see, this is the equation that I get now. And is this balanced? Yes, this is balanced. Okay.
Three, three, yeah. Okay.
See, Abdul, one very important point in balancing of chemical equations is that we cannot change this composition. See, we cannot change this. Nowhere we have changed this part. We have just added or changed the coefficient here. Yes, we have just
Yeah.
added or changed the coefficient here. Are you getting it? I
Yes,
can't
yes.
write it like this H4. No, that's wrong. This is what I have in the equation. I can change it from here, right? Is it clear?
Yes.
So that is how we do this. I'm giving you one question. Will you do that honestly?
I'll try.
Doing that honestly? You will try doing that honestly, or will you try doing that?
What do you mean?
I mean that whatever you try, will you be honest in that trying?
Yeah, yeah.
Yeah, fine. The question is like this. This is a good question. Try to do it very sincerely. Right?
Which is to CuO plus NH3 Cu plus N2 plus H2 Cu plus N2 Cu and N2H3 N2 CuO plus 2N 2NH3 plus Cu plus 2 plus 2O 2NH3 so three no three is it CuO plus 2NH3
Wait. I'm writing. What do you get? CuO plus.
2NH3
Is this the final that you have balanced all the steps? Then are you telling me?
yeah
Okay, fine. 2NH3 then
Cu plus N2
plus
plus what 1H2O
1H2. That means simple H2, right?
yeah
Fine. Abdul, can you tell me what did you do in this? How did you approach this question? First, what did you check? Is the equation balanced or not, right?
yeah
Then what did you do?
um on the left hand side N was
Listen.
what is called
First of all, please try to be a bit louder. I can't really hear you very easily.
on the left hand side N was only one so
Mm-hmm.
I took two to the left hand side then
Mm-hmm.
put it as 2NH3
Mm-hmm.
is equals to Cu plus N2 which is balanced I think
Okay.
and
See,
H2O oh
I told
3H2O
3, 2. See, I told you the first step, bachche, should be to write the elements, right? And we'll see it accordingly. Okay. So, what are the elements present here? Can you tell me?
Cu
Good.
O2
O2.
no O
Oh. Hmm.
N
Hmm.
H
Good. Okay. Now, what is the metal here?
um Cu
What is the non-metal here? Nitrogen. Hmm?
yeah
So this is the first step, this is the second step, this is the third step, and this is the fourth step, right?
yeah
So let's see for copper first. This is the equation. How many atoms of copper here?
One.
How many on this side?
One.
That means it's balanced, right?
Yeah.
I'll move on to the next step. That is nitrogen. How many atoms here?
Two. One.
One. And here two, right? So I will have to balance it. So what do I do? Since I cannot change NH3, I add a 2 there, right? And I get
Yeah.
this equation. Now check whether due to the balancing of nitrogen, is copper still balanced?
Yes.
It is balanced. So now nitrogen has been balanced. What should I do? Should I move to the third step? Bache? Should I check for oxygen now?
Yeah.
How many atoms of oxygen here?
One.
How many here?
One.
Balanced.
Yeah.
Fourth step, hydrogen. How many atoms of hydrogen here?
Three.
2 and H3. How many atoms of hydrogen here, bache?
Two. Two.
If there's 2 here, how did you get 3 H2O?
Yeah. It's three, right?
Atoms. I tell me how many molecules are present here?
Two.
2 molecules of NH3. Are you saying that?
Yeah.
2 molecules of NH3. If I say 1 molecule of NH3, how many atoms of hydrogen are present there? 1 molecule of NH3, if I just write like this,
Three.
3. If I'm saying the quantity has gone to 2 times of this, how many atoms of hydrogen should I have?
Six.
Are you able to realize what you were saying? And what's the correct point?
Six H2O.
See, whatever number we have here in the form of coefficient and whatever number we have here, that is all for that element. Here 2 is also for hydrogen and 3 is also for hydrogen. But for nitrogen, 2 is only there. Yes.
Yeah.
So how many atoms of hydrogen do we get here? We just multiply those numbers.
Six.
Just tell me how many do we have here?
Atoms or molecules?
Atoms, bache. Hydrogen atom.
Uh, Two. Two.
2. I have to have 6 atoms, right? So if I add a 3 here, I will get 3 molecules of water, which will have 6 atoms of hydrogen. Yes.
Yeah.
Now see whether the balancing of hydrogen has also like is the oxygen balanced because of the balancing of hydrogen? Check that.
Yes. No.
No. How many do I oxygen do I have I have here right now?
Three.
3. How many do I have here?
One.
1. So what do I do?
Three CO.
Now see, is nitrogen and copper balanced because of that?
No.
What do I do?
Three CO.
Like this?
Um. Yes.
Yes. Now see 3 copper, 3 copper, 2 nitrogen, 2 nitrogen, 3 oxygen,
Yeah.
3 oxygen, 6 hydrogen, 6 hydrogen. Is it balanced now? Yes, it is balanced. This is the correct one. Do you get it?
Yeah.
Yeah. Moving on to the next part. Should I give you one more example or you are okay with it?
Sure.
Huh? Bache, be a bit louder. Abdul, I'm not able to
Sure.
hear it.
Sure.
Okay. There's this question in the NCRT, so I would want to consult that equation first. Just a second. Hmm. Can you balance this one? Please try balancing this one. This is a
Hmm.
question in the NCRT.
Maybe not. Is that KI?
Yes, yes, that is Ki. PbNO3 whole twice. Ki plus gives you PbI2, okay, plus KNO3. Okay.
What is
See, I've told you the approach 2 times. Please try to follow that approach.
PB a metal?
Yes, that is lead. I wrote it there. See the example. See, I've written there in the last, right?
Yeah.
Keeping this example in mind, I wrote it there. No worries. Right, right.
We're done.
Done. Yes. What is that you get?
PV bracket NO3 bracket 2
Uh-huh.
plus
PB.
2
अच्छा,
KI
okay.
PBI2 plus 2 KNO3.
Let's see it very quickly. Okay. Let's check it. So first of all, how many elements है बचे?
PB
PB,
K
K,
NO3 NO. Oh
Abdul.
wait, no.
Hmm.
Oxygen is different.
Yes. This is a compound.
Hydrogen.
We are talking about elements. Okay. Wherever there's a symbol, that represents one element. Okay, just see how many symbols are here. Pb is one symbol, N is another symbol, O is another symbol, K is another symbol, right?
Yeah. Wait, I think I read it correctly.
Fine.
So
Now,
O.
so let's see Pb, K, N, and I. Yes,
Yeah.
and O.
O.
Correct. So five elements.
Yeah.
Out of these, this is a metal, this is a metal, non-metal,
Yeah.
non-metal, and oxygen. First, we'll balance
Yeah.
either of them. So can I say, can I take lead first?
Yeah.
So how many atoms of lead here?
One.
How many here?
One.
So that's balanced. Come to potassium.
Yeah.
How many K here?
One.
How many K here?
One.
Balanced. Okay. Therefore, now can I take nitrogen here?
Yeah.
How many nitrogen atoms here? Please tell me correctly.
Two.
Sure.
No, no, three, three.
Three or two or six?
Six, 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 sir.
Hmm. Abdul, is this
Yeah,
three for
total number.
oxygen or for nitrogen?
For oxygen.
So is that even a concern with nitrogen? No. But the 2 is for everything which is in the bracket, right?
Yeah.
Therefore, 2 is for nitrogen.
Nitrogen.
So what do I get for nitrogen? How many atoms?
Six. No, no, two, two, two.
Are you getting it or are you just guessing it?
No, no. I'm getting it, but like
Yep.
I'm
This
confusing myself
3
sometimes.
is for oxygen, right? So this is not for nitrogen. But this 2 is for every element present in the bracket. So nitrogen is also
So will
present in
we
the
not
bracket, right?
multiply that?
No, why we will multiply that? For oxygen, we will multiply, see, because these two are for oxygen. Yes.
Yeah.
Are you getting that now?
Yeah, yeah.
Had there been any number here, let's say 2, that would have been for nitrogen and this would have been for nitrogen, then we would have multiplied that. Okay?
Yeah.
I hope that is clear.
Yeah.
It is this, right? So how many nitrogen atoms here in the beginning? That is 2.
Two.
How many are present here?
Um, one, one.
Huh?
One.
1. So what do I need to do? I will add a PbNO3 whole twice plus Ki will give us lead iodide. And since I cannot change this, I will have to add a 2 here, right?
Yeah.
Now, how many nitrogen atoms do I get here?
Two.
2. Now, see, everything that we balanced before that, is that balanced? See, is lead still
Yes.
balanced for this? Is lead
Yeah, yeah.
balanced? Yes, lead is balanced. Is potassium balanced?
No.
How many atoms of potassium here now?
Two.
2. How many here? 1. So, do I add a 2 here?
Yeah.
So, now this is my equation. Now, let's quickly see for iodine. How many iodine atoms here?
Two.
2.
No,
How
no,
many
one, one.
here?
Oh yeah,
Arre
two, two,
bachche,
two.
it is
Two,
2.
two. Two.
How many here?
Two. No, one.
2. Balance. Which is balance? See, 2 is for iodine, right? And
Oh,
this 2
acha,
is for
acha.
iodine and also for potassium. What is the
Yes.
problem?
No, I'm,
Revise.
I'm
Abdul,
getting
revise.
confused.
Yep, revise.
Yeah.
Because we have discussed these concepts, I think, for over 2 months now. Okay, so revise.
Yeah.
Now that therefore iodine is balanced. Now the last element will balance oxygen, right? How many oxygen
Yeah.
atoms here? Tell me the correct answer.
Six.
6. Good. How many here?
Six.
6. How do you get 6? Can you tell me that?
Two and three. Two into three.
So this 2 is for oxygen and this 3 is for oxygen. We multiply them, right?
Yeah.
Fine. So this is the balance equation that we get, and you have done absolutely correctly. That's fine. Excellent. Okay. But
Yeah.
be careful of these small things. Okay.
Yeah, yeah.
Fine. Moving on to the next. Should we move on to the next topic?
Yes.
Do you need one more example to balance it, or should we move on to the next topic? Whatever is your call. Are you confident now with
No,
the
no, I got
balancing?
it.
You
Yeah,
got
yeah.
it. Fine. Now moving on to the next type of, next topic, that is, see, we understood in the beginning of the chapter what is a chemical reaction, right? Then we saw how to represent a chemical reaction, that is through chemical equation. Then we saw that
Yeah.
how to balance the chemical equation, right? What is it that the balancing of chemical equation is based on? Now we are seeing that how many different types of chemical reactions can we have. Yes, therefore the next
Yeah.
topic is types of chemical
Reaction.
reactions. Okay, types of chemical reactions. I'm quickly summarizing all of them here. First is the combination reaction.
Yeah.
Okay. Second is the decomposition reaction. Third is the displacement reaction.
Yeah.
Okay. Fourth is the double displacement reaction.
Yeah.
Fifth is the redox reaction.
Yeah.
Okay. So we are starting with the first type. Now see, these are the types of chemical reactions. Yes. I want to discuss one thing here very quickly, bache. Nature of chemical reaction. Okay. Okay. Nature of chemical reaction. See the difference in nature and types of chemical reaction. I'll give you two examples. Okay. We have either home cooked food, yes,
Yeah.
or outside food, right? Packed food.
Yeah.
Now this is the nature. In home food also we can have biryani, yes. We can
Yeah.
have dal chawal. We can have roti, right? And in
Yeah.
outside food also we can have the same things. Yes. See,
Yeah.
these are different types of food, but this is the nature of food. Are you getting it? Are
Yeah.
you getting it?
Yes. Yes.
But please speak loudly. I am not able to
Yeah.
understand.
Yeah.
Yes. So nature means something very specific, and types of different food or types of different reactions will be different. Okay. So this is the simple explanation here. I hope that is clear with you. Right?
Yes.
So we are going to understand there are two different natures of chemical reactions. Okay. Two different natures of chemical reactions. See, one is either it can be exothermic. What is it? Exothermic. Or the other is endothermic. What is it?
Yeah.
Endo.
Endothermic.
Okay. See, exo means out. Exo means out.
Out.
Endo means in. Endo means in.
In.
Okay. Thermic simply means thermal energy. What is thermal energy? Heat energy. What is heat energy? A form of energy. Yes. What basically
Yeah.
what are we saying? Exothermic are types of are nature of chemical reaction in which we are supplying energy. What are we doing?
Supplying energy.
Sorry, exo means out. That means the energy is coming out, right? So the energy is
Yeah.
coming out. Endo means we
Yeah.
are supplying the energy. We are
Supplying the energy.
so is that clear? Exo means energy coming out,
Yeah.
and endo means energy
Coming in.
being supplied, right?
Yeah.
Okay. Now, the just very important point here, bache. In every reaction, in every reaction, okay, some energy is supplied, okay, and some energy is released, okay.
Yeah.
Okay. There are two scenarios. One is energy supplied is less than the energy released, okay. The
Yeah.
net energy is more, which is released, right? Than the one which has been
Yeah.
supplied. So can I call this as exo one?
Yeah.
Okay. What is the net result happening? The energy is coming out. Yes. The second scenario is energy supplied is more than the energy released. Then what is
Yeah.
happening here in net manner? The energy being supplied is more. So can I call this as endothermic?
Yes.
Is this clear? First point. Now I'll give you one example here. Respiration. What happens in respiration? Energy is being supplied, right? Or
Yeah.
energy is being released in respiration. See, we need the energy for respiration to take place. But overall energy which is released is more than the energy used, right?
Yes.
Can I call respiration exothermic?
Yes.
Yeah, I hope that that is clear to you now.
Yeah.
Fine. So now the first type of chemical reaction is the combination reaction. What is the
Combination reaction.
see? What do we mean by combination? To mix, right? I say
Mm.
combination of two dishes. I mix those dishes, right? So what is happening
Okay.
here? How we define combination reaction when two or more reactants, two or more reactants. Okay.
Varieties.
If you want, you can write it. Although we have it in the NCRT, if you want, you can write it in simple words. Combine together to give you one product. How many product?
One.
One. And how many reactants? Minimum two. We can have more than two. Is it clear?
Yes.
Then that type of chemical reaction is called as a combination reaction. Okay. The example. Let's see the example with you. H2 plus O2 gives you H2O, right? How many
Yeah.
reactants do we have here?
Um. Two.
How many products do we have here?
One.
One. So can I call this as a combination reaction? Yes.
Yeah.
Example, carbon plus oxygen gives you carbon dioxide, right?
Yeah.
Again, combination reaction. Any other example that you can give me right now for combination reaction?
Fe plus O2.
Fe plus,
O2.
excellent, right? Dot
Yeah.
XH2, this is one product plus H2, right? Excellent.
Yeah.
What else?
Um. Cu plus O2.
I'm coming to, can I say this? See, NaCl? Yes.
Yes. Yeah.
What did you say? Cu plus O2, right?
Yeah.
We will get copper oxide. Good.
Yes.
Okay. Calcium plus
Yeah.
oxygen gives you calcium oxide. So all these are
Yeah.
what? All these are examples of.
Exothermic reaction.
I'll give you one example here, Bache. This is what methane, right? CH4 is methane.
Yeah.
If methane is burning, I will get something like carbon dioxide and water, right?
Yeah.
Can I call this as a combination reaction? Yes. Okay.
Yeah.
So any confusion here?
No.
Acha. Now we have discussed this type of chemical reaction. We will also have to discuss the nature, right? Either it will be endothermic or it will be exothermic, right? See,
Yes.
please pay attention here. Generally, combination reactions, okay, this is a reaction, okay. Combination reactions are exothermic in nature. What is the nature?
Exothermic.
Means energy will be supplied, I mean, released out, right? In nature.
Yes.
But there is one exception, okay. But
Yes.
to give nitric oxide, this reaction, although the combination reaction is endothermic. What is it?
Endothermic.
Is it clear?
Yeah.
So the type is combination, but the nature is exo or endo depending on the whatever energy is more. Okay.
Yeah.
Should I move on to the next?
Yes.
The second type of reaction we have is decomposition reaction. What is it?
Decomposition also.
See, what do we mean by decomposition? To break, right? To break into smaller parts.
Yeah.
How do we define this? When one reactant decomposes or breaks down into smaller compounds, right? Simpler compounds.
Yeah.
Clear? See example. Can you give me one example here? Hmm. Any example here?
Catalyst decomposition breaks down into smaller compounds.
See, look here, bache, look here. H2O
H2O,
breaks into
yeah.
H2 plus O2. Is this
And
decomposition here?
yeah,
Yeah.
NaCl is equals to Na plus Cl.
If that happens, okay,
Yeah.
fine. So this is one thing here. This is one example, okay. Now see, important point, bache. Generally, endothermic in nature. What is the nature?
Endothermic.
That means energy will be supplied, right?
Yeah.
So when the energy is supplied, we can have different sources or forms of energy.
Yeah.
Yes. So based on the source of energy, we can have different types of decomposition reaction. Okay. If we are using heat
Yeah.
energy, it is called as a thermal decomposition. What is it called as?
Thermal decomposition.
Okay, thermal means heat. Okay.
Yeah.
Example, we have it in the book. I think Fe2, something like that. I'll quickly see the NCRT here. Okay. Second is, what is the second one? If I'm saying the source of energy is electric current, source of energy is,
Electric current.
that is called as electrolysis. See,
Yeah.
lysis means to break down. Lysis means to
Breakdown.
break down in the presence of electric current. Is it correct?
Yeah.
Example, this is very important, Abdul, and this is very much in the like asked in the exam. H2O is actually decomposed into hydrogen and oxygen using electrolysis. What is the method of decomposition of water? Electrolysis. Is it okay?
Yeah.
And the third one, Vache, I'll quickly write here. The ratio of hydrogen to oxygen in the electrolysis of water is 2:1. What is the ratio?
H.
2:1. Okay, hydrogen to
Yeah.
oxygen. The ratio is, see, we are getting hydrogen and oxygen, right?
Yeah.
What is the ratio of the amounts that we get? Two times of hydrogen and one time of oxygen. Is it clear?
Yeah.
And oxygen is formed on anode, which is the positive electrode, bache,
Yeah.
and hydrogen is formed on the cathode,
Yeah.
which is the negative electrode. Okay, these two questions are important from this electrolysis of water. Here,
Yeah.
the third type of energy is the sun energy or the light energy. Okay, that is called as
Yeah.
photolysis.
Photolysis.
See, lysis again means to break down. Yes, photo means
Yeah.
light. Photo means,
Light.
so therefore break down in the presence of light. Okay, break down in the
Yeah.
presence of light. So
Light.
sunlight is one example here. Okay, what is sunlight? Sunlight is a form of light. Yes, which has energy. We all know that. Okay.
Yeah.
So example, if we have AgCl, okay, if we have AgCl and if we keep it in the sunlight, okay, what do? We keep it in the sunlight, okay.
Sunlight.
We will see that Ag gets, and we get this. So AgCl was basically like grayish black in color, okay, and we get this
Yeah.
Ag here, totally different. Is it okay?
Yes.
So can you see this is the compound and this is the element of this thing, silver, right? Elemental
Yeah.
of a silver element in the elemental form. Is it okay?
Yes.
And this is happening in the presence of sunlight. Any confusion here?
No.
I'll quickly open the NCRT so that we can go through that and you're okay with that.
Yeah. So again, endothermic is in and exothermic is supplying, right?
Overall, if overall if the energy being supplied is more, that means given in is more, it's endothermic. Overall, the energy
Yeah.
released is more, that means coming out is more, it's exothermic. Okay,
Okay.
fine. See, types of chemical reaction. Let's quickly see the combination reaction. Okay, so what do? Take understand this activity. We take calcium oxide. What do we take? Calcium oxide. Okay,
Okay.
and we add water to this. What do we add? Water. Okay,
Water.
we will get calcium hydroxide and we will get heat. That means, can I
Yeah.
say it is exothermic in nature, bache?
Yes.
And see, we had two reactants and we are getting one product. Can I call this as a combination reaction?
Yeah.
See, this is important. Okay, is it okay?
Yep. Yeah.
In this reaction, calcium oxide and water combine together to form a single product, that is calcium hydroxide. Such a reaction in which a single product is formed from two or more reactants is known as a combination reaction. See, we discussed this, right?
Yeah.
Now coming on to the next point, see. Burning of coal, carbon, oxygen gives you carbon dioxide. I've already discussed all these examples, okay? See,
Yeah. Yeah.
in simple language, we can say that when two or more substances, that could be element or compound, substances could be both elements or compounds, yes, combine to form a single
Yeah.
product, the reactions are called as combination reaction.
Combination reactions.
We observe that large amount of heat is evolved. This makes the reaction mixture warm. Obviously, if heat is evolved, the mixture would be warm, right? The products would be
Yeah.
warmed. Reactions in which heat is released along with the formation of product are called as exothermic
Chemical reactions.
chemical reactions. Okay. So burning of natural gas is exothermic. Obviously, we will get water. I mean, we will get heat energy
Yeah.
there, right? Now see, Abdul
Yeah.
Bacha one thing. See, this is a combination reaction. Okay. We are getting carbon
Yeah.
dioxide along with water. Now, water will be mostly in the gaseous form. Okay. We are not really considering that as it. Okay.
Yeah.
See, do you know that respiration is an exothermic process? Yes. Okay. So this is the reason why respiration is an exothermic process. You should go through that. Okay. This is the equation for respiration. This is important. Okay. See what are
Yeah.
we having? This is glucose. This is one substance. This is oxygen. This is another substance. Okay. What do we get? We get carbon dioxide, we get water, and we get energy. Therefore, it is
Yeah.
exothermic in nature.
Exothermic reaction. Yeah.
Right. See. Now this is important, Bachche. The decomposition of vegetable matter into compost is an example of an exothermic reaction. Although decomposition is taking place, but what is the nature of this chemical reaction? Abdul,
Yeah.
decomposition of vegetable, although is an example of decomposition, that is very clear, right? But what is the
Yeah.
nature of this reaction?
Exothermic reaction.
Exothermic. So this is one exception that although the reaction is decomposition, but the nature is exothermic. Please take this example, okay?
Yeah.
Okay. Now decomposition reactions. We have ferrous sulfate. What do we have? Ferrous sulfate. It's a compound, okay? We heat it. What do? We heat it. And we get different color. Ferrous sulfate was green in color. What was the color? Green
Green.
color. And we heat it. We get ferric oxide, sulfur dioxide, and sulfur trioxide. The color in the beaker changes to red or brown. Why does that happen?
Yeah.
Because earlier we had green color because of ferrous sulfate. Now ferrous sulfate has been decomposed into ferric oxide. Therefore, the color will change. Is it okay?
Yeah.
Fine. So you can please go through that very quickly. Okay. You will go through this.
Yep.
Fine. So I'm stopping it here. Just once again, I quickly want to give you one thing. You will go through this activity. I have discussed this in the class. Okay.
Yeah.
Now see this example. We had silver chloride. We put it in the sunlight, we get silver and chlorine. Yes. Silver chloride
Yeah.
turns gray in sunlight to form silver. Earlier it was black. Now it has changed to gray. Why has it changed to gray? Because silver has been formed. And what is the color of silver? It's gray, right?
Yep.
So any confusion here?
No.
In the next class, inshallah, we'll start with the displacement.